Hi, welcome to this video presentation by Unknown India YouTube channel. Please view it on a laptop or desktop or tablet for better video quality and use a headphone, earphone or earbuds for better audio quality. The Indian civilization is fascinating with several unique aspects. We all think that we have a very good understanding of it, but there are several misconceptions about the Indian civilization, mainly due to ignorance, but sometimes also due to prejudice. In part 1 of the video, we addressed misconceptions numbers 1 to 5. In part 2 of the video, misconception numbers 6, 7 and 8 partly. In this third part, we are going to continue with misconception number 8 and complete it, and also part of misconception number 9. In this video, we will address and remove these misconceptions based on authentic information derived from solid evidence based on knowledge contained in and references to events in Vedic and other ancient texts, official documented archaeological excavation reports of the Archaeological Survey of India, and research papers and articles by eminent persons published in both international and Indian journals of repute. All the references to these and other resources used in this video are given in the description below. Please check them out. Continuation of misconception number 8. Indian astronomy was copied from Greeks and other Westerners. A quick recap of what we covered in part 2 video. Indians discovered and knew very well about heliocentric theory, elliptical orbits of planets, and axial precession of Earth. Not only that, their calculation of precession was very close to modern scientific estimate of NASA, whereas the Greeks were a long way off. If you missed that video, you can check it out as per the link in the description below. The ancient and eminent Indian astronomer Aryabhata discovered about the diurnal motion or daily spin rotation of the Earth, which makes all celestial bodies such as stars and the Sun look as if they are moving around the Earth in circular paths. He has commented in Shloka 9 of chapter 4 of Golapada in his book Aryabhatiya of 499 CE. Thus, just as a person in a boat moving forward sees the stationary objects on the bank as moving backwards, the stationary stars at the equator are seen as moving towards the west. The Europeans had to wait till 1851 CE to know of this, when Leon Foucault, a French physicist, proposed the diurnal rotation theory, demonstrating it with rotation of the plane of oscillation of a freely suspended pendulum. So, who copied whom, viewers can decide. Parasara, not the sage who was grandson of Maharishi Vasishta and father of Vyasa, but an ancient Indian astronomer, wrote a wonderful astronomical treatise in prose style called Parasara Samhita, also known as Parasara Tantra, which is full of quantitative astronomical data. It is dated at 1400 BCE as per positions of stars in different seasons described therein. It is very well expounded by Professor R.N. Iyengar, formerly of the Indian Institute of Science, Bangalore, and now the director of the Center for Ancient History and Culture in Jain University, Bangalore, in his book and article referenced below in the description. Parasara says Jupiter travelling 2¼ nakshatras in a year leads to good crops, thereby giving the orbit cycle of Jupiter as 12 years, calculated as 27 nakshatras divided by 2¼ This is a very accurate estimate for ancient times, considering that the most modern value of the Jupiter orbit cycle is 11.86 years. In another passage, a long one, Parasara talks about the visibility cycle of Venus, comprising 270 days of visibility in the east, followed by 68 days of invisibility, again followed by 240 days of visibility in the west, and then 13 days of invisibility again, thus adding up to a total cycle of 591 days. This is remarkably close to the modern estimate of Venus cycle as 263 plus 50 plus 263 plus 8, totaling 584 days. In yet another passage he says, Saturn's travel for 27 stars is for 28 years, again amazingly close to the modern value of 29.4 years for the orbital cycle of Saturn. There are many more such quantitative indicators for astronomical parameters in Parasara's work. These served as valuable data for subsequent generations of Indian astronomers like Aryabhata, Bhaskara 1 and 2, Varahamihira, Brahmagupta, etc. Amazing stuff from Indian astronomers long before the Greeks arrived on the scene. We wish the Western scholars who ridiculed Indian astronomy as a copy of Greek and Babylonian astronomy had cared to study Parasara's works, setting aside their obnoxious prejudice. You may remember that we had set out to disprove misconception number 8 by examining the three prominent aspects of ancient Indian astronomy. We have so far highlighted the astronomical discoveries of ancient Indians, 3 of them in the previous video and 2 in this video. Now it is time to look at the second aspect, namely recording of some important astronomical events by the ancient Indians. Ancient Indians had observed and recorded in Vedic and other texts several important astronomical phenomena such as solar and lunar eclipses, planetary transits and conjunctions, lunar occultations of stars, heliacal risings of stars, passages of comets, sunspots, solar flares and storms, etc. Due to limitation of time, we will just talk about 2 of them briefly. We thank Dr. Raj Vedam for information on both of these. His article and video talk are both referenced in the description below. Please check them out if you are interested. The first one is a powerful solar event encoded in the form of a story in several ancient texts including the Rig Veda and Markandeya, Matsya and Vishnu Puranas, passed on to generations of Indians. It is about the sun emitting unbearable heat and brilliance at a point of time in the past just before it went to cooler regions at its southernmost point. Of particular relevance are verses mentioning the appearance of the Ashwini Nakshatra at dawn for their share of the sacrifice, pointing to a heliacal rising, that is over the eastern horizon before dawn, of Ashwini Nakshatra, or the twin stars of Beta Arietis as per Western nomenclature. Bal Gangadhar Tilak and later Professor Abhayankar both proposed that this story actually encodes the Ashwini Nakshatra in the winter solstice position, and they used the phenomenon of precession to estimate the dating of Ashwini Nakshatra at the winter solstice position and heliacal rising in 7200 BCE plus or minus 80 years. Recently, 2 scientific research papers published in Nature and Communications have confirmed a very major solar corona mass ejection or CME event that happened in the year 7176 BCE as evidenced by the ice cores in the Arctic as well as tree rings. This was a cataclysmic solar storm which has been amazingly recorded by Indians. Obviously, they could observe such astronomical events even over 9,000 years ago. The second one is about astronomer Brahmagupta, who lived during the period 598 to 668 of Common Era, who in his work Brahmafuta Siddhanta, written around 628 of Common Era, has recorded occurrences of eclipses as well as transits of planets like Mercury and Venus, and very ingeniously used the data on these to calculate planetary diameters, orbit rate and duration, distance from Earth, etc. He has also worked out guidelines to predict these events. In the Western world, such observations and predictions of transits could become possible only after Galileo invented the telescope in 1610, which enabled availability of massive observed astronomical data to Kepler and others in the 1630s. Is it not amazing that Indian astronomers could routinely make these observations and predictions centuries before the Western astronomers and especially the Greeks could? We have so far looked at the astronomical discoveries and records of events made by ancient Indians. The question arises, how did they observe all these celestial objects and phenomena? So, it is time to look at the third aspect of ancient Indian astronomy, namely the astronomical instruments and devices used by ancient Indians. Water clocks to measure very small time intervals have been used by Indians as evidenced by excavations at Harappan sites dating back to 3000 BCE. They are also mentioned in the Vedanga Jyotisha of 1400 BCE. A vastly improved design model, the Jal Chakra Yantra, was used by Bhaskaracharya in the 12th century CE. This Harappan circular platform with graduated concentric circles excavated in 1946 was used as a sundial in ancient India. Aryabhata of the 5th century Common Era used the Shankhu Yantra made of ivory. Later, Bhaskaracharya in the 12th century CE also refers to its use. The Gola Yantra, which is an armillary sphere used to observe celestial objects and measure their position coordinates, is mentioned in the ancient Surya Siddhanta. Bhaskaracharya, in his Siddhanta Shiromani, gives detailed instructions on how to construct it. Lalla, the 8th century astronomer who lived in central India, has mentioned 12 yantras or gadgets in his book. Some of them are shown here. So, in conclusion, we can say very confidently that from all the evidence presented so far, it is very clear that the ancient Indians had the knowledge to observe celestial bodies, determine their positions, and record celestial events for posterity over 9,000 years ago. They had devised simple astronomical instruments as far back as 5,000 years ago. Therefore, the statements of Western scholars accusing Indians of copying Greeks, Babylonians, and others are very prejudiced and ridiculous. Misconception number 9. Indians learnt mathematics from Greeks, Arabs, and others. This is a preposterous twist of truth because the rest of the world actually learnt most of the mathematics from India. We will prove this with a few examples. While there is a lot of debate and disagreement on who invented the zero, the Indians or Mesopotamians or Babylonians, there is none at all as far as the decimal number system is concerned. It was in India that the decimal based numbers started getting used first, even for day-to-day purposes. And we all know how important the decimal system is in developing modern mathematics, science, computers, software, digital platforms and products, artificial intelligence, etc. Apart from mentioning the primary numbers from 1 to 9, 10 and its multiples from 20 to 70 are mentioned in this verse of Rigveda. Its meaning, O Indra, come thou hither, having harnessed thy car with 20, 30, 40 horses. Come thou with 50 well-trained coursers, Indra, 60 or 70 to drink the Soma. And as per another Rigveda verse, the Marut gods were prayed for 3 times 60 for benefits, and as per yet another Rigveda verse, Indra was prayed for horses thrice 7 times 70. This shows the popular day-to-day use of the decimal system in ancient Hindu world, even from the time of the Rigveda, that is 6000 to 6500 years ago. The link to our video on the age of the Rigveda is given in the description below. The 10 verses in Prapataka or chapter 2 of Kanda or book number 7 of the Taittiriya Samhita of the Krishna Yajurveda are completely devoted to numbers. The last verse, 7.2.20, lists out the Sanskrit names of all the powers of 10, right up to 10 to the power of 12. Thus, 10,000 is Ayuta, 100,000 is Niyuta, million is Prayuta, 10 million Arbuda, 100 million Nyayatuda, billion Samudra, 10 billion Madhya, 100 billion Anta, 1000 billion Parardha. The Taittiriya Samhita is 4375 years old. We have a video on its age as per the link in the description below. Similarly, the Vajasneyi Samhita of the Shukla Yajurveda, which is over 4,500 years old, in chapter 17, mantra 2, also lists these large numbers of the decimal system like 100,000, million, billion, etc. in the context of prayers for bestowings and blessings from the deity Agni. Thus, the Vedic Indians knew and used the decimal number system even as early as 6,500 years ago. It was refined and developed further by the great Indian mathematician Brahmagupta. Brahmagupta's texts were translated into Arabic by Muhammad al-Fazari, an astronomer and mathematician, under the names of Sindh Hind and Arakan towards the late 8th century CE. An immediate outcome was the spread of the decimal number system used in the texts to the Middle East. The mathematician Al-Khwarizmi, who lived during the period 800 to 850 of Common Era, wrote a text called Al-Jam wal Tafriq bi Isal al-Hind, meaning addition and subtraction in Indian arithmetic, which was translated into Latin in the later 13th century as Algorithmi de Numero Indorum. Thus, through these texts, the decimal number system and Brahmagupta's algorithms for arithmetic have spread throughout the world, first to Middle East and later to Europe. And very wrongly, the Indian decimal number system is attributed to Arab. Please check out our other videos in the full playlist and also subscribe to our channel by clicking the respective links. Thank you.